Those actually take about 20 minutes to do each problem, so we'll try to speed up the process and maybe do 2 from each. You can use elimination method or substitution to shrink that to 2 equations by 2 unknowns. Notice my notes on the screen, I eliminated y. If you look at the notes, I'm changing my mind today. I'm going to eliminate x. And the reason I chose x, I could eliminate z, really doesn't matter, because to eliminate x, I'll take these 2 equations, multiply this by what? -2, and that will eliminate x. Then I'll take either this and this or this and this to eliminate x. So I'm going to eliminate x, just to be different, because I get bored if I do the same thing. And by eliminating x, this will happen what? You can shrink to 2 equations by 2 unknowns. So you can take this, eliminate x or eliminate y, eliminate z, it doesn't matter which one. So let me take equation number 1, which is 4x plus y plus 3z equals 1. Let's look at these 2 equations. Let me multiply the second one by -2 to eliminate x. If I multiply by -2, what are you going to have? -4x plus what? 4y minus, you're multiplying by -2, 12z equals -22. So I multiply this by what? -2? And let's add them. And now you have what? 5y minus what? Is it 9z? Equals -21. Now I need another equation with 2 unknowns. I can either use the first and the third or the second and the third. It looks like the second and the third will be easier. If I take the second and the third and I multiply the second one by 3, I can eliminate x. What's 3 times 2x? 6x. What's 3 times a -2y? -6y. What's 3 times 6? 18z equals what? 33? And leave the bottom equation the same. And now let's add them. And what do you notice about the x's? Gone, because my goal was to eliminate x. So I got -6 plus 3, that's -3y, plus what? 30z equals what? 29? So I took the 3 equations by 3 unknowns, and I shrunk them now to 2 equations by 2 unknowns. There is one of them, there's the other one. And I can use any method I want now to solve those 2 equations by 2 unknowns. So I can take them, because that sheet is almost full. I put them on a new sheet of paper. I go, okay, this is what I have right now. And solve them any way you want. Any method. You can use substitution, you can use elimination method, you can use determinants for 2 by 2, whatever method you want to use. So which one you want to use here? Any preference? What is it? Elimination by addition? Okay. What do you want to eliminate? Why? To eliminate y, I got to multiply this by what? 3, and this one by 5. 3 times 5, 15y, minus 3 times 9 is what? 27z, negative 63. 15y plus, oh God, big numbers, 150z equals, where's my calculator? I think that's 145. 29 times 5, 145. Let's add them. Gone. 123z equals 82. Hopefully my numbers are good. Negative 27, just making sure. That's 150, 123. So if I did the other part correct, if I multiplied correctly here, didn't screw things up, 21. I'm just making sure here. That's negative 3y. Negative 6, that's negative 3y. That's 18. 33. It looks good, I think. So now what is z equal to? 82 over 123. I wasn't looking for numbers like these. I was hoping for whole numbers, you know. I was praying for some good numbers that didn't work out here. Now let's solve for y. Grab either equation. 5y minus 9z, 9 times z, which is what? 82 over 123 equals negative 21. I know both of these numbers. Can you divide 123 by 9? No, you can't. I know you can divide it by 3. By 3, this is 3. By 3, what's 123 divided by 3? Oh. 123 divided by 3 is 41, he said? Oh, God. 123 divided by 3, 41. I got like 10 different answers. Oh, 41? Oh, I can simplify 82 and 123, I guess, huh? They're both divisible by 41. If you divide them by 41, I just didn't know that number is divisible by 41. So you can simplify z equals what? 2/3. That makes my life easy. 82, both are divisible by 41. I just didn't see that. So instead of using that crazy number, or even if I'd left it there, by 41, this is a 2 here. So 5y minus 3 times 2, which is 6, equals negative 21. 5y equals what? Negative 15. Y equals negative 3. I got z and I got y. Now I need to find x. You grab any one of those equations, doesn't matter which one. 4x plus y plus 3z equals 1. 4x plus y is negative 3, plus z is what? 3z. 2/3 times 3. or 3 times 2/3. 4x minus 3 plus 2 is equal to 1. 4x minus 1 is equal to 1. 4x equals 2. X equals 1/2. So my solution now, and I won't test it, is x is always first, 1/2, y is always second, -3, and z is always third, alphabetical. 1/2, -3, and 2/3. I didn't realize 82 over 123 was 2/3, till we divided this by 41. Like, oh, wait a minute, So that's really what we do. We try to take the 3 equations by 3 unknowns. You can use elimination method or substitution. You shrink it from 3 by 3 to 2 by 2, then you solve it. I'll do the next one with substitution, just to show you it's the same thing. I'll make one up. I'll try to make the answers nice and neat. Let me try another one. Let's make that a 14 here. Let's make that 13. Let's make that a 0. As I said, you can use the addition method or substitution to shrink that to 2 equations by 2 unknowns. I did the elimination method on the other one. I'll use the substitution here. Notice I can take the top equation, solve it for z. And if I solve that for z, it's going to be what? 14 minus 3x minus 2y. You agree with that one? Now, go to this equation, the last 2 here, and replace z with that. Use a substitution method and clean them. And you will shrink that to 2 equations by 2 unknown. Let's take the first one. 5x minus 4y plus 6 times z. Z is what? 14 minus 3x minus 2y. And you want that to equal to 13. Clean that one. Six times 14. 84. Minus 6 times 3, 18x. Minus 6 times 2 is 12y equals 13. What is 5x minus the 18x? I'm collecting like terms. 5x minus 18x is what? Negative 13x. What's negative 4y minus 12y? Negative 16y equals 13 minus the 84. Is that a negative 71? Notice they're all negative. Can you see them? Every one of them is negative. Why not multiply by a minus 1, just to get rid of the minus signs? 13x plus 16y equals 71. The other one, take the second equation and replace z with 14 minus 3x minus 2y. Again, instead of z, let's put 14 minus 3x minus 2y is equal to 0. Four times 14, is that 56? Negative 12x minus 8y. Wow, this is perfect. I didn't plan it that way. I did not plan it this way. What's 4x minus 12x? Negative 8x. What's 8y minus 8y? It's actually 0y. Equals what? Negative 56. And that's my second equation. I lucked out here, because when you write these two equations now, and the other one, I don't even have to write the 0y. You have negative 8x equals negative 56. Can you solve for x? You divide by negative 8. X equals what? 56 divided by 8, is that 7? If it's 7, I'm in trouble there. I didn't plan it that way. I must screw it up there. 3 times 3 is 9. 9 plus 4 plus 1. 15. 15 minus 8 is 7. 7 and 6, 13. 12. 12 plus, oh, I know why I screwed up on the last number. In my mind, I had 3, 2, 1 for an answer. I made 3, 2, 1. So the first two are good, but I goofed on this. Because if 3, 2, 1, it should be 12 plus 16 plus 4. I had a minus here in my head somehow. But I end up with a better problem so far. X is 7. Can I find y? Right here. Now y might be a fraction. 13 times 7 plus 16y equals 71. (91) plus 16y equals 71. Take the 91 there. What's 71 minus 91? Negative 20. What is y equal to? Negative 20 over 16. You can divide them both by 4. Negative 5 over 4. If I know x and y, can I find z? It's 14 minus 3x minus 2y. That's what z is from the top, right here. Let's plug in the numbers. 14 minus 3 times x is 7 minus 2 times negative 5 over 4. This will be a plus. Is that 5 over 2? 10 over 4, which is 5 over 2. What's 14 minus 21? Negative 7? Now, if you want to add or subtract, you need the LCD. That's negative 14 over 2 plus 5 over 2, which is negative 9 over 2. So your solution, x is always first, y is always second, and z is always third. One little mistake I made to change my answers. I meant them to be 3, 2, 1. I goofed on this one. That should not have been a 0. Should have been 12 plus 16 plus 4. 4 times 3, 12 plus 16. 32 should have been. If I made it 32, I won't have any fractions. Now, they're a lengthy process. I'm going to show you a different way of doing it. It's called determinant. And that's the last piece, then we out. I'll do 2 examples on that. Kramer's rule again.